students, welcome back to my channel Explore Physics, Let's Explore. How are you all doing? In previous class, I've explained about light. It's a form of energy. Then the minimum requirements to see any object. Then we spoke about reflection and regular and irregular reflection of light. In this class today, I'm going to talk about laws of reflection, different types of images, images formed by a concave mirror or convex mirror and a plane mirror, and few terms related to spherical mirrors. So let's start today's class. We have already discussed about reflection. Today we are going to talk about the laws of reflection. So for that I'll explain you with an activity which you have done in lower classes. So let's say we have one plane mirror M dash. Okay, and we have one ray which strikes it at point O. So we have one light ray which strikes on this plane mirror at point O. This is the point of incidence O. After reflection, it goes back in this direction. So, after reflection, it goes back like this. So, let's assume we have ON, a normal. Say this is normal to the point of incidence, and let's give it the name. Say this is IO and this is OR, where what is I? I is the incident ray, the ray which strikes the surface at O. This O is what? Is the point of incidence, and this OR is what? It's the reflected ray, right? So we have IO, ON and OR, where ON is the normal to the point of incidence. So what exactly is this? Say MM dash is a plane mirror. IO ray strikes at point O, that is point of incidence, and after reflection it goes back as OR. This is the reflection by a plane mirror. This angle is called angle of incidence, and this is angle of reflection. So what is ION is called angle of incidence, and NOR is called the angle of reflection. So the angle between the incident ray and the normal is called angle of incidence, whereas the angle between the normal and the reflected ray is called angle of reflection. Children, you always get confused because you always think when it comes in numerical form that this is the angle of incidence, which is wrong. This ION is the angle of incidence. Please take ON as a reference line. So the angle between the incident ray and the normal is referred as angle of incidence, whereas the angle between the reflected ray and the normal is referred as angle of reflection. So I don't think there is any confusion in it. So what are the laws of reflection? 1. Angle I is equal to angle R. That is, angle of incidence is always equal to angle of reflection. The angle between normal and incident ray is I, the angle between normal and reflected rays R. So these two are equal. That means when the light strikes any surface, so it goes back making the same angle with the normal. Now the second law is the incident ray, normal and reflected ray, they all lie in the same plane. So what does it mean? I'll explain you. So that is the incident ray, normal to the point of incidence and reflected ray they all lie in the same plane. What does it mean? They all lie in the same plane. What does it mean? See, this is the plane of the whiteboard on which I am drawing this ray diagram. So, the incident ray, normal and reflected ray, obviously they all lie in the same plane. So, the second point says that incident ray, or the second law says rather, that incident ray, normal to the point of incidence and reflected ray, they all lie in the same plane. So, these two are the laws of reflection. What is that? 1. The angle of incidence is always equal to angle of reflection. And 2. Incident ray, normal to the point of incidence and reflected ray, they all lie in the same plane. That is all about the laws of reflection of light. So, I don't think there is any problem in this. So, the next we are going to talk about types of images. So, we have types of images. So, one is called real image and the second type of images are called virtual image. So, what is meant by real images? The images which can be taken on screen, are called real images. Which can be taken on screen. Whereas the virtual images cannot be taken on screen. That is the first difference between the virtual and real images. And the second is real images are always inverted, whereas the virtual images are always erect. So we have the types of images, real images and virtual images. The images which can be taken on screen are called real images and the images which cannot be taken on screen are called virtual images. Real images are always inverted, whereas virtual images are always erect. So these two types of images we'll be talking about when we talk about the ray diagrams and all. I hope this is clear to you. So now you know about real and virtual images. We'll be talking about the spherical mirrors now. There are two types of spherical mirrors, concave and convex mirrors. So, spherical mirrors mean the mirrors which are formed from a sphere or which are not plane. In the last diagram, when I was talking about the reflection through a plane mirror, we have seen that the mirror were plane, not curved. Here we are talking about the spherical mirrors which is made from a sphere, or which are the mirrors which are curved. These are called, where the reflecting surfaces are curved, these are called the spherical mirrors. You all must have observed the spoons in your home. If you hold it like this, so this caving part resembles the concave mirror and bulging out part resembles the convex mirror. So, as the name suggests, concave mirror, where the mirror is in this shape, it is caving in. Okay, so this is a concave mirror, whereas the convex mirror, the reflecting surface is bulging out. So this is the main difference between concave and convex mirror. Of course, the difference between the images formed by these two mirrors are also there, which we'll be talking about in detail. So as of now, concave mirror and convex mirror, and the name suggests the caving in part which caves in is called the concave mirror, where the reflecting surface is caved in, that is concave mirror, and when the reflecting surface is bulging out, it is called convex mirror. There are terms which are related to it. I am going to talk about this now. So how does it happen? How can we make the concave and convex mirrors? So if you see, say we have a big sphere made up of glass, of course. If I am going to take this part and I am going to paint or polish this side, then this is the reflecting surface which is shiny. So which kind of mirror it will be? It will be a convex mirror. It will be a convex mirror, bulging out. The reflecting surface is bulging out. Whereas if I am going to cut this part and I am going to paint this part so that this is the reflecting surface, so this will be my concave mirror. This is convex mirror, right? Now this, the center of this mirror, this sphere, sorry. So there is, naturally if it's a sphere, it has to have one center. This C is called the center of curvature. Again, I'll be explaining you in detail. So for a concave mirror, it lies within, or it lies in front of the mirror. If you see it, this is my concave mirror. So naturally, it lies in front of the center of curvature lies in front of the mirror. Whereas if I am going to talk about this convex mirror, so it lies behind the mirror. This is center of curvature. Now I will be talking in diagram, I will be explaining you different terms pertaining to spherical mirrors. And what are these? Talking about in detail now. Children, after this class, I have the slides which I will be running over. So this will take care of complete notes of what I am explaining you today. Please do write and do subscribe and like my channel if you like the content in it. So when we talk about, or we'll talk about concave mirror. What will happen here? If I'm going to take a big mirror, this is the back of it where I'm just making this short small lines. So this was a part of this side of, say it was suppose it's a glass file like this, then this part is the concave mirror. So naturally the center of curvature will be somewhere here. The center of curvature is what? Is the center of the sphere from which it is made up of. The central point or the midpoint of the mirror is called pole. This is a pole, and the line which passes through these two, usually we refer it with P. So the line which passes these two means this pole and the center of curvature is called radius of curvature. So if this is P, then CP is the radius of curvature, where P is the center point of the concave mirror and C is the center of the point from which the mirror is made up of. Then we have, let's say this is MM dash, then the diameter of this reflecting surface, that is MM dash, is called aperture. So this MM dash is what? Aperture. This is the aperture of the mirror, and M dash is the aperture of the mirror. So this is, again I am explaining you, C center of curvature, CP radius of curvature, P pole, MM dash is the aperture. The line which passes through CP is called principal axis. The line which passes through CP is called principal axis. So this is all about the concave mirror. Now let's talk about the convex mirror. All the terms about the convex mirror, how can we depict it? So let's assume we have a convex mirror here, which is M dash. Now this mirror is part of the sphere, so the center of that sphere lies behind the mirror. So this will be C, center of curvature. Same thing happens here, the midpoint of the refracting surface or convex mirror is called pole. The line which passes through CP is called the principal axis. So here P is the center of the mirror, which is referred as pole. C is the center of the sphere from which this mirror is made up of, is called center of curvature. PC is called radius of curvature. And the line passing through PC is called principal axis. Again, the diameter of the refracting surface, that is mm dash, is called aperture. So this is called aperture of the mirror. So we have all these things here which is pertaining to convex mirror. So all the terms related to convex mirror is here. I don't think you'll have the problem because, as I told you before, after this the slides will be running through and that will take care of all the notes. So after this we'll be talking about the images formed or the properties of the images formed by a plane mirror, a concave mirror and a convex mirror. So we talk about the images formed by a plane mirror, a concave mirror, and a convex mirror. So we'll be talking about. So now we'll be talking about the images formed by a plane mirror, a concave mirror, and a convex mirror. So how are the images formed? For a plane mirror, what are the properties of the plane mirror? So for a plane mirror, the image is always virtual and erect. We all see our reflection or image in a plane mirror, no? You have never seen yourself upside down. It's always virtual and erect. So the first property of the image found by a plane mirror, that the image is virtual and erect. 2, it's laterally inverted. I hope you all have observed that the left of yourself or left of the object is always the right of the image and vice versa. So the images are laterally inverted, means left of the image is right of the object and so on. 3, it's of same size. The images are of same size, means if I am looking at myself in a plane mirror, the size or the height of my image will be the same. It's not like I'll be shorter or taller. I'm talking about a plane mirror. So you may have a combination of mirror you have seen in the amusement park and all. I'm not talking about all these combination of mirror, but for a regular plane mirror, it always forms the image which is of same size as of the object. And fourth, very important, distance of the image, the distance between the mirror and the object is same as the distance between the mirror and the image. If you move further or forward and backward. So you'll see the image also will be moving accordingly. So the distance between the plane mirror and the object is same as the distance between the plane mirror and the image. So that is the fourth property, that the distance between these two are the same. Now what about the concave mirror? What happens in a concave mirror, or the images formed by concave mirror? So the images which are formed by concave mirror, one is real, or image is real, and when it is real it is inverted, except one case. We'll be talking about this case and we'll talk about the image formation by a concave mirror. So as of now, you remember the concave mirror make real and inverted image, except one case where the image formed is virtual and erect. So it means that concave mirrors can make real as well as virtual images. It all depends on the position of the object where it is placed. Otherwise, you can remember that it makes real and inverted image barring one case where the object is very close to the mirror, or which is when the object is between focus and the pole. Second, that it may be diminished or magnified depending upon the position of the object. So the images formed may be diminished or magnified. It all depends where the object is placed. So that is these are the properties of images formed by a concave mirror, that they make real and inverted barring one case where the object is very closely placed to the mirror, and the images may be diminished or magnified. It all depends where the object is placed. Now what about the images formed by convex mirrors? Remember, it's easy to remember also that one, always remember the images are always virtual and erect, and two, always diminished, always smaller in size. So the convex mirror always make the images which are virtual and erect, and two, the images are always diminished or smaller in size. So easy to remember for plane mirror and convex mirror. But for concave mirror, you have to just see whether it is real or whether it is virtual, whether it is diminished or it is magnified. All depends on the placing or the position of the object. So that is all about the images formed by a plane mirror, a concave mirror and a convex mirror. So you please do me a favor, you can do one thing, whatever utensils you have in your house, just see the inner side or the outer side, whether it is caving in or it is bulging out. Depending upon that, you can see how the images are formed. You just take yourself or the object or the vessel further or move it closer to you and see how the images are formed. That is the task for you which you have to remember. Do like my channel if you like the content, and don't forget to see the slides because which are running over after this class. I will take care of all the notes. Bye bye and have a nice day. Thank you.